Ready, math. Okay. All right, guys.
Oh, whoops.
So as promised, we're getting to the more difficult stuff.
You're off camera.
The good news about it is that once we get through this, the other conics are going to seem easy. That's good. We could do this the other way. We could get through the easy stuff, kind of get you comfortable, but then ending with hard stuff is never really fun. So I want to get this out of the way. What?
You should tell your Parabolas joke.
Well, now that you've ruined it. Well, everyone knows it. I've had all of these. Well, almost. All right. So let's take sort of a similar approach to what we did yesterday. Okay. The question is really, what is a parabola? Okay, that's sort of your motivating question du jour. What is a parabola? Okay, so let's get some ideas. If I said to you, define a parabola. You're out in the world, and I asked you to define it.
It's a symmetric, bilateral.
Bilateral?
Something that's like split down.
Bilateral?
Well, like it's split down the middle and it's repeating on both sides.
Symmetrical. Okay.
It's bilateral as it's down both.
Bilateral.
Okay. So it has something to do with symmetry, right? But that still doesn't define it, right? That'd be like I said to you, you know, what is a book? And I said pages. Well, it doesn't define what book is. So what else? I mean, define a parabola. How do you say what a parabola is?
It's a U.
Okay, so it's a U. All right, that gives us some sense of what the shape is. It's a U. It's got symmetry.
Doesn't have a vertex.
It has a vertex. Again, has a vertex doesn't really define it. It just tells me something about it. But good.
No.
Yeah.
Well, it goes on forever.
Good. So it's infinite in its direction. It's either going to go all the way up or all the way down. Okay.
Wait.
Yeah.
It never goes straight.
Correct. Yeah. These are not linear. They're curved. Right. The branches on it are curved. Yep. True. No intersection lines. Okay. So we're building up a lot of characteristics. You still really don't have a definition. Okay. You guys know from Algebra 2 and Algebra 1 that parabolas go like that, and how else? Like that. They just go down, right? You know what happens now? Now they go like this.
But that's not a function.
And they go like that. Correct. It's not a function, but they're still lovely graphs. So what we're going to look at today is, first of all, what a parabola is, and how on earth do you get a parabola to open left and open right, as opposed to opening up and opening down. The up and down part you guys are used to. The left and right part you're not. So, here we go. Here's what a parabola is in pre-calculus. A parabola is the locus. What a great word.
I was going to say that.
The locus of all points, okay, that are, or who are, if we're making them people. The locus of all points that are equidistant.
I love that word.
This is sounding very
Sounds like a
circle-esque, right? And our definition of circle started, I think, identically yesterday. A parabola, though, is the locus of all points that are equidistant from a fixed just means staying still, meaning that it's not going to change. From a fixed point called a focus, F-O-C-U-S, fixed point called a focus, and a line called, we're almost done, a directrix. That is what a parabola is. A parabola is not a U-y thing. A parabola is not something that has symmetry. Parabola is not a vertex. A vertex is a part of a parabola, but a parabola is not defined as a vertex. A parabola is the set of all points who are equal in distance, equidistant, from some point whose name is called a focus, and some line whose name is a directrix. Could we complicate this any further?
What's a direct?
I think not. We don't know yet. That's what a parabola is. Parabola has never been that in your life before. A parabola has never needed to be this. But now, that's what it is. Okay, before we draw, well, you know what, yeah, let's do the drawing now. Let me show you what this looks like. So, let's take the red definition and try to construct this using some kind of picture. We're not going to use numbers, and we're not going to really label exact values. We're just going to sort of try to see what this looks like. So maybe on your paper, I don't know, 4 or 5 lines tall. Okay, so get yourself some kind of grid. And we're going to draw, or I'm going to attempt to draw, something that satisfies those conditions in red. And here's going to be my best attempt. The parabolas that we're going to look at are not as steep as the ones that you guys are used to. Right? You guys are used to ones that are pretty narrow, right? They're usually pretty close together in terms of their, sides or their halves. These are going to be a lot wider. So it's going to look something like this.
Does it?
Okay, it's going to go through the origin. Okay? But notice how that looks significantly wider than what you guys are used to in terms of a parabola. Okay? I didn't draw it wonderfully, but
I thought it was supposed to be a star.
we're going to, but I didn't want to start with the most confusing thing. Let's start with what you guys know. So here's a parabola. Now, what on earth is all this red stuff? A parabola is the set of all points, meaning everywhere on that black line or curve. So maybe here's a point, and maybe here is a point. Right? It doesn't matter where I put the dot. I'm just picking one. Okay? It is the set of all points that is equidistant, equal in distant, from a fixed point called a focus. So I'm going to put my focus on
Oh, we did that last.
the y-axis. And we're going to label this, shockingly, F. That's the focal point. Yeah.
But the ones like front on the sides aren't the same as like something like all the way up and
It'll work. If you draw it perfectly, it'll work. Now, we still don't have this directrix thing, okay? The focus is always sort of inside the curve of the parabola. It's always like getting eaten, kind of like on the inside part. The directrix is always outside of it, okay? So here's what your directrix might look like. It's going to look something like...
oh, it's 111.
Make it a dotted line, guys, because it's technically not, like, part of the graph. Like, if you were to graph this on your calculator, it's not going to put a directrix, but it's there as sort of a teaching sort of tool and method. Here's what a parabola is. Now, whether or not I drew this perfectly, that's not the point. But a parabola is defined such that any point on its curve has an equal distance from the focus point and the directrix. Here's what that means. That would mean, guys, that this point, or this distance rather, from there to there, let's just go nuts and call it D1, should be equal. If I drew this perfectly parabolic, okay, should be equal, guys, to that distance, D2. And remember from geometry,
Oh,
you
but all
can
the
use...
D's aren't the same. Like
Correct.
that's what I was trying to say.
Yes,
Like, that
that's
that wouldn't work.
Remember those symbols from geometry where you sort of mark the lines like that? It shows that they're equal. Again, whether or not you believe me that that's perfect, it's probably not. It's pretty good. I've certainly done worse. But the parabola